All right, actually, I'm going to go through two types of pattern problems that were a little more challenging than what we saw. Okay, the first one I am going to start with a 0. And I'm just going to use kind of simple numbers here. All right. So when we went through our patterns and finding the equation to represent the patterns, the couple things that I asked you to look for is look to see what is the change in the y's. Okay, so the change in the y's here, it's doing what each time in this example? Yeah, so it's adding 5 each time. All right, so in all the examples that I gave, I didn't realize that they were going to give you patterns that were slightly different than this. All the examples I gave you had the x's changing by 1. But this one, the x isn't changing by 1, right? The x is changing by what? 3. So the x is changing by 3. So when you're looking to put this linear relationship into the slope-intercept form, you have to account for the slope. The slope is the change in y's over the change in x's. So what is the change in y? It's a plus 5. And what is the change in x? Plus 3. And so that is your slope. So that's the rate of change. 5/3 winds up being your rate of change. And then what was our y-intercept when the x value was 0, y was 5. Okay, so this would be the way that you would solve this type of question. Okay, now let's take a look then at the problem like 23. And so here the x's do increase by 1. The y's, when you're looking at them, do increase by a constant value. And so let's take a look at what this looks like. Okay, so here, what is the change that's occurring? Each time the y's change by 7, right? Okay, so right away we get this equation. Y is equal to, and then the change in x's is plus 1, so you don't have to worry about it. It's just a 7 as your slope. X, and so what you need to do is figure out at what value or when will it be a 0 here. Okay? So you can either count it backwards. So here you can look, if you wanted to, you can go basically 3. When it's 3, this goes down by 7. Right? So you can continue to count it down in that form. Okay, or what you can do is use what we would call the slope-intercept form, just like you would when we write equations. If you wanted to find what this b value is, so this is a b, not a 6, right? So the y-intercept, what you could do is you could take one set of coordinates, it doesn't matter which ones, one pair of x and y coordinates, and plug them in here. So let's say we just take the first one. So we plug a 12 in for y. So when y is 12, the corresponding x value was 4. And you want to find what would this y-intercept, this b value, need to be for that to be true. So you get 4 times 7 is 28. If you subtract a 28 from both sides, you get negative 16 is equal to your b value. So if we just replace this now, we get our solution. Y is equal to 7x minus a 16. And that's how you would find that particular